I have discussed here the limiting value of x taken as independent variable when the value of x is near to a. L is a fixed value. L1, L2, L3, values of L1, L2, L3 will be to that fixed value. If A, B, I say constant, then x tends to a minus and x tends to a plus, implying x tends to a, x tends to a, or x approaches a. And you remember always that in this case x is not equal to a. Thus, I have discussed here the limiting value of x taken as independent variable when the value of x is near to a, never x equal to a. Now we move to the case x and y are related. Already I have mentioned x is independent variable and y, that is fx, is dependent variable. Corresponding to the limiting value of x, we are going to discuss the limiting value of fx, that is y. We represent that by writing limiting value of fx as x tends to a, or limiting value of y as x tends to a. Sometimes we write limiting value in short form LIN, also LT. As x tends to a, let limit of fx or limiting value of fx be small a. Now let us clarify the meaning of this one. x tends to a means x can take value which are greater than or less than, bit greater than or bit less than a, and for each of those values, value of fx is say L1, L2, L3, etc. And we find that value of each of these is near to L. Value of each of L1, L2, L3 near to L. That means L is a fixed value. L1, L2, L3, values of L1, L2, L3 will be to that fixed value, near to that fixed value L. In that case, we say limiting value of fx as x tends to a is L. Thus, when x tends to a, fx is equal to L. Here two cases arise. When x tends to a minus, that is limit x tends to a minus fx. This is called left hand limit. Okay. This is called left hand limit. When x tends to a plus, that is limit x tends to a plus fx. This is called and if we find the value of left hand limit, that is limit x tends to a minus fx, say L, and right hand limit, that is x tends to a plus fx, that is also L. Both left hand limits and right hand limits have the same value, where L is finite number. Then we say limit x tends to a fx equal to L. Thus, we can say the condition of existence of limit x tends to a fx is equal to L is limit x tends to a minus fx is equal to limit x tends to a plus fx, both of which will be equal to L. The condition of existence of the limiting value limit x tends to a fx equal to L, this is also called left hand limit, this is right hand limit. Also we have the symbols LFA, short form of left hand limit, RFA, short form of right hand limit. Both must be equal to a finite number L. Then we say limiting value of fx as x tends to a is L. Next we come to basic limits. Now we are going to discuss basic limits. That means the values of each of these limits can be obtained from our previous knowledge. Limit x tends to 0, x to the power n equal to 0, where in positive number. Limit x tends to a fx equal to fa, where fx is a polynomial. Then limit x tends to 0, sin x equal to 0. We have the value sin 0 equal to 0 and values of sin x when x is near to 0 is taken to be 0. Then limit x tends to 0, cos x equal to 1. These are the basic limits. We can use this easily when we need. Next we will come fundamental limits. Fundamental limits. Number 1, limit x tends to a if n be any rational number, then limiting value of x to the power n minus a to the power n divided by x minus a as x tends to a will be equal to n into a to the power n minus 1. And limit x tends to 0, sin x divided by x is equal to 1. These two fundamental limits are included in class 11. Hence, we shall confine within these two. In the next class, I shall work out different sums on these two fundamental limits. Now, I am going to write down the theorems or laws of limit, and at the end part I shall discuss geometrical view as well as analytical view of this one. If c be a fixed number, then limiting value of c as x tends to a will be equal to c if fx and phi x be two functions of x, then limit of the sum of two functions fx and phi x or difference of the two functions fx and phi x will be equal to we call sum of difference formula. Next, limit x tends to a, product of two functions will be equal to the product of limits. We can use cross like multiplication symbol, or we can use dot. Number 4, limit of quotient of two functions fx and phi x, limit x tends to a, fx by phi x is equal to quotient of limits of fx and phi x, that is limit x tends to a fx divided by limit x tends to a phi x. And it is quite natural that this denominator cannot be 0. Limit x tends to a phi x if c be constant, then limiting value of the product of c and fx will be equal to c into limiting value of fx. These are the theorems to be used